So my goal with this course is to introduce this really large array of cartographic and data visualization tools and features that we have in QGIS these days. And in my opinion, this is probably the area where QGIS has grown the most. If you go back, look at the new features over the last 2 or 3 years. So this course is designed more for me to be demonstrating the techniques, but of course, if you're welcome to follow along as you can. I'll be recording this session, providing this to you so that you can go ahead and complete the assignment, which I'll give to you at the end of the course today. And the assignment will essentially be you working with the data and trying these techniques on your own. And I have assigned some screenshots that you take of your completed results and turn into me to show that you were able to work with these techniques successfully. So again, my name is Kurt Menke. I've been working at Septima for a little over a year now, and I do a mix of spatial analysis, cartography, and teaching. I'm a QGIS certified instructor, so anyone who turns in the assignments for this course will get a QGIS certified QGIS certificate for the course. And I'm also a QGIS author, so I have written several books on QGIS. QGIS for hydrological applications on the left is recipes for catchment hydrology and water management. So it's a very book specific to that field, but it does also include a lot of data visualization techniques, some of which we'll cover in this course. The book on the right is probably of more interest to people taking this course, Discover QGIS 3X. This has it has 5 parts, and part 4 is on cartography, and part 5 is on advanced data visualization. So there's a lot of good exercises in this book that will take a deeper dive than what we will do in this course. So this could be of interest. I'm actually in the process of updating this, so there'll be a second edition of this book coming out in a few months. So this is the course schedule. Today we'll go for 2 hours. We'll take a break after an hour. And I'll be giving you an assignment to finish before the second class, which will happen next Thursday, same time, same Zoom link. Next week, this time there'll be a question and answer session, which will be a chance for you to log in and ask any questions you had, or help you get over any difficulties that you had with the techniques of the software. And yeah, next Thursday we'll have the second session and another question and answer session after that course period the following week. So these are going to be the course topics, and it's going to be a little bit, it's like a 20-minute sample of each. So there's this is again designed to kind of give you an overall view of all the different techniques there are in QGIS. And my hope is that you can then understand enough of these to start trying them out on your own data and going further with them than we did in the course. So today we're going to focus on some things you can do with print layouts. We're going to look at layer effects, which are things like drop shadows and outer glows that you can apply to vector features. We're going to look at the elevation renderers in QGIS, and that will kind of segue into looking at blending modes. And we'll look at both layer and feature blending modes and some use cases for those. And then we'll look at rendering point data, because there are some point specific renderers in QGIS that are quite useful. And then we'll finish up the morning looking at coastal cartographic effects. On the second day, we're going to be looking at some more advanced techniques, looking at cartographic processing tools and expression-based symbology. That's really probably one of the secret powers of QGIS, is these things called data-defined overrides, where you can, instead of just defining a color or setting a parameter for a symbology parameter, you can use an expression in place of that. And so there's a lot you can do with those. And that will tie into geometry generators, which is a way to use an expression to transmute or change the geometry and the rendering of data. Quite powerful. And then there's going to be finishing up the second day with 3 different ways to animate data in QGIS. We're going to look at the temporal controller, which allows you to animate any kind of data that has a time component to it. We'll look at the 3D viewer, and you can also use that to create 3D fly-throughs of terrain. And then we'll finish out looking at weather-related mesh data and how you can, again, animate that because there's a time component to that. So it'll kind of tie into the temporal controller again and show you how you can animate that kind of data. And I should say, feel free to ask questions at any point during the course. These are the resources that you will have. I'm recording this session and I will provide it after the course. I've created short videos of each task. So it may be, there's different ways of learning. There's also a step-by-step detailed document of each procedure. So you can either read the step-by-step instructions, or you can simply watch a 5 or 6 minute YouTube video to learn how to do a procedure. So you'll get both of those, and then we'll have the Q&A session next week. So this morning, I'm going to start out looking at custom legend patches and some labeling tricks you can use in a print composer. So let's just get out of this and into QGIS. So I am using QGIS version 3.22, and I'm going to go to the browser panel to the course data. I've set this up as a favorite. If you're not familiar with favorites, you can simply browse to the course material on your hard drive, wherever you've downloaded that, and you can right-click on a folder and choose Add as a Favorite, so that makes the data easier to find. So I've set the favorite to the course data folder, and we're going to be starting out in this folder named Denmark. So there's a number of folders in here. We're going to be using different data for different techniques. So we'll be opening up a lot of different map documents. If I expand the Denmark folder, and we'll find a Denmark geo package. And I have 2 different QGIS projects in this geo package. We're going to start with this one named Denmark. So I can simply drag that onto the map canvas to open this. And you may get a message that this was created in an older version of QGIS. I think I used 3.16 to create these, and I'm now using 3.22. So if I now switch to the layers panel, you can see we have kind of just a basic map of kind of southeastern Denmark. We have towns, airports, roads, forests, a water layer, municipalities, and a second water layer. Why is that? That's the Baltic Sea label. Yes. So here, this layer here named water. Well, let me back up a second. I'm also going to be using the layer styling panel quite a bit. And if you're not familiar with this, it's really the most intuitive way to work with symbology in QGIS now. You can certainly, for a layer like towns, double click on it to open up layer properties and work with the symbology tab and do all the styling changes you need to do. But the problem with this technique is that it's blocking the map, especially if you're on a single monitor. And you can make a change to the layer, but then you have to click apply or OK to see the change on the map. Whereas if I use this layer styling panel, which I can access by clicking this button on the upper left side of the layers panel, I can use this panel to make changes to a layer style and see the result on the map immediately. So, and there's an undo at the bottom here. So it gives you access to all the same symbology tools, but just a much nicer environment to work with. So here we have this water layer, and you notice this is using this renderer called no symbols. So sometimes this is a renderer that can be handy if you just want a layer on the map for labeling purposes only, and you don't need to see the actual features on the map. So there's a use case for that. This is actually the Baltic Sea label. So if I turn this off, you see that Baltic Sea label disappearing. And we have some other nice cartography here. We have this forest layer, which is using this random marker fill in combination with the SVG marker. And to bring up my PowerPoint again, this is one of the areas that is so special about QGIS, is that we have all of these different renderers, and most people are familiar with using categorized or graduated renderers to show different, like what's called a choropleth map, where you show numbers across polygons using a graduated renderer, or a categorized one where maybe you want to show each municipality in a different color. But there are some very unique renderers in QGIS, such as these that we'll look at today, for points, point displacement, point cluster, and heat map, that allow you to render tightly clustered points in a much more helpful way. If we look at the raster renderers here, we have ones for satellite imagery, multi-band color. We have unique values for categorical rasters. The default is single band gray. And then we have single band pseudocolor, which is for coloring things like an elevation surface. But we also have hillshade and contours, which we can use to create both of those renderings of a DEM without actually having to create a new file on disk. We're just rendering a DEM as those. And whenever we can use symbology for that, when we don't actually need to layer, that's kind of a win, to not have to produce more layers when all we needed was a hillshade for a map. We can just render the DEM that way. And then we have these renderers called symbol layer types. And there are symbol layer types specific to point, line, and polygon. And we can start using these in combinations to come up with some very nice effects. So we're going to look at this morning inverted polygon shape burst fills using the inverted polygon renderer in combination with shape burst. And the forest that I just showed you was using the random marker fill and SVG fill. So you can use multiple symbol layer types for a style as well. So these are quite powerful, and so it's always good to remember that you have all these options. We look at the symbol layer type. We have a lot of different choices to choose from. And so I just want to point out some of the symbology here. So what we're going to do, though, is focus on the print composition on this map. So I'm going to go to the project menu, and under layouts, I already have a layout created. And this is just a simple map for demonstration purposes. And one thing that is a nice feature in QGIS is, we have this label Baltic Sea, and we may want to move the title, and so if you're playing with a position for the title, we may put it in a position where it starts conflicting with that Baltic Sea label. And of course, we could go back to the map canvas and move that Baltic Sea label out of the way to account for this, but there's a more elegant approach to this now. I can select my map object, and with the map object selected, go to the Item Properties tab, and we have the series of buttons across item properties when we have a map selected. And this one with the label icon is labeling settings. And here I can, in the label blocking items, I can choose different map elements, such as a title or a legend, to be label blocking items. So if I choose the title as a label blocking item, and then I again try to move this to this part of the map, you'll see the label get out of its way. So that's a very nice feature when we start getting maps with a lot of labels that are kind of busy, and we start having more and more map elements on them. We can set up various items to be label blocking. So if I decided I might want to put the legend up in this portion of the map, I can set that again to a label blocking item. There's one other label setting that's handy, and you get to this from the layer properties itself. If I go to the labeling tab for this water that is controlling the Baltic Sea label, there's this button here off to the right that's easy to miss, automated placement settings. And if I click this, by default, it says it's allowing truncated labels on the edges of a map. That means that if I have a lot of labels on this layer, I may end up with, depending on how I set my map extent in my print composition, I might have a label that's cut off at the edge of the map. But if I uncheck this, it will force those labels to move so that they're either fully on the map or fully off the map within the print composition. So that's another useful label setting to be aware of. So what we're going to look at next here are, bring up the print composition again. So here we have our legend, and it's, it's a fine legend, but we're using these default straight lines for roads and rectangles for polygons. And now in QGIS, there are, it's possible to create custom legend patches for these. And there's a nice shortcut to accessing these. I'll bring up my browser. I'll put this URL in the chat. So this URL is for a GitHub repository for custom legend patches that the community of users has just put up here for other users to download and use. So if I scroll down on this page, we can see a screenshot of the style manager with different legend patch shapes in there. And if we scroll further down, we can see an example of these being used. And so it's much more intuitive and kind of sets the map apart a little bit when we can have an actual building footprint be the legend patch for buildings in the legend, and the same for this water drain pipe. We get much more intuitive legends. So we can quickly download and use some of these, and the ones I'm going to have us use are this ones from Claes Carlson, who's a Swedish QGIS enthusiast. And I'm going to click on the link for his patch XML file. And it opens up this big XML document. And what we need to do here is click on this raw button so that we open up the actual XML file in the browser. And we're going to just copy and paste this URL for this XML document into the style manager of QGIS. So copied that link. I'm going to bring up the main QGIS window again, and I'll open up this style manager, which is this button right here. So with the style manager open, if you haven't used this, there are tabs for point, which are called marker symbols, line symbols, polygon or fill symbols. These are all default symbols that ship with QGIS. There's a series of color ramps. You can store text formats, which would be for title text, for example, on a layout. You can store that as a text setting that you can easily apply to other layouts. There's label settings. And then we have legend patch shapes. So here it ships with no legend patch shapes. It's blank, but I can import these. So I'm going to go down to the import export, import items. And in this dialog that opens, we can import from a file, but we can also import from a URL. So I'm going to paste that URL in here, and click Fetch Items. And it will download the series of legend patch shapes from his XML document. And here you have a choice to tag these. It has a kind of a default tag of imported, which I choose not to use. You can choose to add these to favorites, and you can select individual patches, or you can simply select all and then choose import. So now if I go back to my legend patch shapes, I will see all of those available to me now. So I can close this. And actually, while we're here, these are all created using expressions. So for example, if I click on one of these point patches and double click on it to open up the properties for it, you will see the expression that was used to create this legend patch shape. So it's using the multi-point function, and the same is going to be the case for the different lines, multi-line string in this case, and polygons. So all of these are just created by using a point line or polygon function and coordinate pairs for the vertices of that. So you can just create your own from scratch. Now, if I bring up my print composition again, they're in my style library now, so I can select this legend. And over here in my item properties for my legend, I could apply these to all these road segments. So I could double click on this. And when I double click on the road item, this is where I can change the actual text, but I can also change the shape, which is the shape of the legend patch. So if I click on that, clear this out. So I will see all the legend patch shapes that I have that apply to line geometries. So contours, rivers, and I get a couple for roads. I'll choose roads 1, and now I have roads 1 applied to each one of those. And you could go in and you could choose a different patch for different aspects of this. I could choose a different patch for primary roads if I wanted to. I could make that roads 2. So you can really come up with a very custom legend. And I can do the same for the polygons. So for municipalities, I could choose a different patch. Like that. So that's really nice. But I also want to show you now how you can create your own. So I'm going to minimize and bring back up the main QGIS window. And if I want to come up with a nice legend patch shape for forest that actually looks like one of the forested polygons, it's just a matter of finding one that I like. And I'm going to zoom in to the center of the map. Some of these are quite complicated and would not lend themselves very well to appearing in a legend. But this one is a much more regular polygon. So I'm going to choose this one. And to create a legend patch shape from this forested polygon, I simply have to put the layer in edit mode and use the select features by area button and just click on that to select that feature. So I have that selected feature in edit mode, and then I just click on this on the editing digitizing toolbar. There's a copy features button. I simply copy that feature. And now I can bring up my style manager again, because I have that feature on the clipboard. I can go to my legend patch shapes tab. And instead of going to import export, I can click this green plus button and choose fill legend patch shape, since it's going to be a polygon. And when I choose a new one, it comes up with a default expression for just a square. And I'm going to delete that and paste. Just going to hit Control V to paste the geometry from my clipboard into this box. So it pastes in the JSON for this feature. And I have to do a little bit of editing because it includes, among other things, all the attributes as well as the geometry. So I don't need all of this extra material at the end. So what you want to look for is near the end of this expression, there are 3 closing parentheses. And this is always the case. So you just want to remove everything after those 3 closing parentheses. So delete those. So the end of the expression is those closing parentheses, and then I scroll to the top, and it's going to start with this multi-polygon Z function. So again, I don't need any of these column names that are coming before that. So I'll just select those and delete, take out the extra line. So my expression starts with multi-polygon Z and ends with the 3 closing parentheses. And then I can click Save Legend Patch Shape, and I can give it a name, such as Forest 1, if I think I'll have more than one, and click Save. Let's see, did it? So there it is. So there is Forest 1 in my library of legend patch shapes. And if I double click on it, I'll see the same geometry that I just edited in there. So it's actually quite quick to choose a geometry that you want to base a legend patch shape on. And so you can start building your library of legend patch shapes for the data that you work with. So you have very nice custom intuitive legend patch shapes for all your maps. So now I can simply, I'll take this layer back out of edit mode and clear the selected features. Go back to the previous extent and bring up my print composition, and I can apply that to forest by the same technique. I'm going to choose a polygon. You'll just get the potential polygon ones. There's Forest 1, and click OK. And you can also adjust the size of these. So you can start increasing the width and height of different legend patch shapes here to, in this case, to make it big enough so that some of those SVG tree icons actually fill the patch, for example. So you can experiment with resizing those as you need as well. So that's legend patch shapes. Any questions on that? So the next thing we're going to look at is layer effects. So I will bring up QGIS again and go to the browser panel. And I'm next going to go into the layer effects folder. And I'm going to open up this bathymetry project. And if you are working with me, you can save this. I'm going to discard it in my case. So this is a different map. This is a map with layers from Natural Earth, which is a nice online repository of kind of just standard country boundaries, state boundaries, water, airports, rivers, things like that, they're global and all work well together. And one of the things they have are bathymetry polygons for different ocean depths. So here, I've already applied a layer effect to these polygons. And just to remind you of what these are, live layer effects are different ways to apply these effects to vector features. So the ones that are commonly used are inner glow, inner shadow, outer glow, and drop shadow. There are a few more in addition to these, and for each one of these, you can set specific parameters for them and customize them. So these have been in QGIS for quite a while. They've been there since QGIS version 2.10, I think. So what I'm going to do is to find these is select this bottom bathymetry layer, and I see the style for this, just a light blue, and I want to expand layer rendering. And you'll see this option for draw effects. And that's how you enable effects for a layer. And in this case, the effect has already been applied. And we'll take a look at that as soon as I turn these on. So these have already been enabled. I just need to turn on effects for each one of these layers. So it gets a little repetitive, but start looking at the coastline as I enable effects for each one of these, and you'll start seeing a pretty interesting cartographic effect start happening. We started seeing almost a 2.5D rendering of the depth of the ocean features. I think here in the Atlantic, that's about the deepest as it gets. I think these top few are for Marianas Trench in the Pacific and some of the deeper places. But we get this really nice effect where we see the kind of the shelf of different elevation or water depths in the ocean. So if I look at what was done to create this, I can just choose one of those layers and click on the little yellow star for draw effects. And that's how I access the effects properties. And you can see there's an inner shadow that's been enabled. So this is using an inner shadow. It's using most of the default settings for this, but I reduced the size of the inner shadow. So I think this is a 2.5, I think is the default, and I reduced it to 1. And I also tinkered with the blur radius and made the color a light gray instead of black. So for each one of these, you can change those parameters. And one interesting thing here is you'll see this item called source. Source is the source symbology for the layer that you've interacted with. So if I turn off source, it will turn off the symbology for that feature, and all you're left with is the effect. And that can be interesting sometimes too, just to have a drop shadow without the layer symbology being part of it, just the shadow itself. While I'm in here, there's also, this is, I think, just legacy. They could probably expand this list, but the list just includes these 4, which are probably the most popular and have the most use cases. But if I select inner glow, for example, there's an effect type menu below. And this menu is a little bit larger. So for example, there's blur, colorize, transform. So I could replace inner glow with blur if I select this, so that blur becomes one of the options here. So you can access more of these effects and tinker with them. This is one area where you kind of have to experiment and see what kind of effects you can create. There's a lot of ways people have used these, but they're, you know, very creative uses and usually very data specific uses. The next example I'm going to show is also in this layer effects folder, and there's a DK Coast geo package here that I'm going to expand, and there's a QGIS project in there called DK Coast. So I'm going to load this. Again, I will choose to discard my changes here. So there's an annual event called the November Map Challenge. And so this was a map that I produced one afternoon for the November Map Challenge that I thought would be fun for this course. I was interested in the idea that in Denmark, you're close to the coast almost wherever you are. So I created a series of interior buffers to show, these are 5 kilometers each, to show how close you are to the coast in each part of Denmark. And I have this kind of border effect down here. I should have this actually go extend to the border because I realize this isn't really the coast here. But other than that, it was a very interesting effect. And so I was thinking about how I could make this visualization a little more interesting to look at. And so I thought of layer effects. And if I go in down here to layer rendering, to draw effects, and I turn on one of these effects, such as drop shadow, it will put a drop shadow under the entire layer, which is fine. And I can, experiment with changing the size of that drop shadow and the blur radius, the blur radius is how smoothly the drop shadow fades from full shadow to not. So you can play with those things. But then another thing you can do in QGIS, there's this master symbol layer. So for example, if I want to change the colors of one of these classes, I can go in and change that color for that one particular class or the symbology for that particular class. But if I want to change something on all these classes simultaneously, I click this symbol button. So if I go in here and make a change to all the layers, I can choose the simple fill component and apply an effect at this level. And what this will do is apply the effect to each individual class of these interior buffers. So if I choose draw effect here, and again choose drop shadow, I get this very interesting appearance of the same data. And so for this, I just decided that was a little bit too severe. So I reduced the default width here down to 0.4. Just to make the shadow a little less bold. And then this blur radius, I also reduced that. I think I put it down to 0.8 or something like that, which again, it kind of, the effect is still there, but a little more elegant looking to my eye anyway. So this is another use case of using a layer effect. And there are some strange artifacts that appear here. And one thing I can tell you is that if you put this into a print composition and export it, those disappear. It's kind of a rendering artifact on the map canvas that does not carry forward to the print composition for whatever reason. And while I was here, I was also playing with other effects. So first thing I looked at was inner shadow. And if I use inner shadow, it creates a very strange look of the same data. So again, it's always worth just experimenting with these, remembering that they're there when you're trying to come up for an interesting visualization and seeing what happens when you apply some of these, because sometimes you can accidentally stumble across a very interesting effect. So there are some other common uses of these. One thing people will do is produce neon effects using an outer glow. So here, these flight lines have been set up with an outer glow effect. And for the outer glow, the default is just a white outer glow, but there's also an option in that effect to use a color ramp. So here I set up a custom color ramp between the color of the flight path line and the background of the map. I think it's a very, looks black. I think it's a very dark gray. And so that the outer glow fades from the color of the line to the background of the map to create this kind of neon look. And that's something people often do. And you can also use, this is another example of a fun map I made last fall for that same challenge. And for UFO sightings in Denmark, I just use an outer glow around the country boundary with using a green color. So a lot of these effects will look really interesting on a dark background too. That's another factor to consider. But the outer glow can be very helpful even for just maybe, so these are not, you know, professional maps that you'd use in a work setting. You can also use these effects to elevate features off a background map. So using the same strategy where you're using an outer glow between the background of the map and the color of your feature can sometimes help lift that feature off the map a little bit, or applying a subtle drop shadow to a feature can again lift the focus, that focus feature off the map when the map is kind of busy, and give it a little more visual weight. So any questions on layer effects?
Not yet, I think. Perhaps
Okay.
later.
Yes.
Thank you.
Okay, so moving on, we're going to look at some of the elevation renderers in QGIS. This is a very practical exercise. I'm going to be working with something in the elevation folder, and I have two projects for Mount Rainier. The one that's underscore 3D we'll be working with in the 3D environment. I'm going to use this Mount Rainier project here. There's also a Danish DEM from Måns Klint that you can work with if you want to explore some Danish data. I'm using the Mount Rainier because it's a very dramatic DEM, and it's also quite small and good for demonstration purposes. So here is just a DEM in QGIS, and when you first add a DEM to QGIS, it's always going to use this single band gray renderer by default, and it's showing the highest elevations in white and the lowest elevations in black, and stretching those across the DEM. So if we want to create a colored DEM, the renderer we would use is single band pseudo color. So I'll go ahead and choose single band pseudo color, and if you've been working with a color ramp recently, it usually chooses that by default. But we have you know, a long list of these are what are end up being favorite color ramps. So if we go back to the working with the style manager, if you set a color ramp to be a favorite, it will show up in this list. If it's not, it'll be in the all color ramps portion of this. And so there are a lot of different color ramps here, but I want one that doesn't ship with QGIS by default. So I'm going to click the drop down and choose create new color ramp. And when we do that, we can choose gradient or some other options. Gradient is how I created that neon effect for the outer glow. I created a gradient color ramp between the pink and the black background in that case. Here I'm going to choose CPT City. And this is a small library of color ramps that ships with QGIS, but you have to access it this way. So when I choose CPT City, I get a series of color ramps kind of divided by category. And I'm going to choose topography since I'm working with elevation. And we see 15 or 20 color ramps specific for topography. And I've come over the years to really appreciate CDA and SDA. They work for a wide variety of terrains. It's worth exploring some of these others because they may work for your area of interest better. But I'll just go ahead and choose SDA for this and click OK. And it styles my data based on that color ramp. If this is a color ramp that I would like to continue to use, I can click this drop down, or no, where is that setting? To save it. But yeah, if I click this save color ramp, I can make this, I can add this to my style manager. So I'll just call it SDA. And add to favorites, and click save. And since I added that to favorites, it will now show up in this first list here. So you can manage your color ramps fairly easily that way. So now we have a color DEM, and I'm going to now work with the hillshade renderer. So I'm going to just duplicate this. And I'm going to rename this copy DEM as hillshade, so I can keep track of my different layers, and turn this on. And I'm going to, I'll turn off the DEM for now. And instead of single band pseudo color, I'll choose hillshade. And it now renders that same DEM as a hillshade image. And there's one thing to be aware of. Down here, there's this resampling section. And when you're using this renderer, you may have your default settings be nearest neighbor resampling for both zoomed in and zoomed out. And what can happen with that is you now see a little bit of banding or striations in the data. If you zoom in, you'll see these kind of gridded artifacts in the DEM, just in the way it's being rendered. And we can remove those by choosing a different resampling method, and bilinear almost always improves the look. So you can see if I choose bilinear, it gets rid of that gridding, it smooths out the DEM. So now we're going to kind of segue into blending modes. And blending modes are another thing like layer effects that have been in QGIS for quite a while. So there are 13 different blending modes in QGIS. And I would say we're going to use this one called multiply, which is probably the most commonly used one. And this is probably the most common use case of using a blending mode, is to create a color hillshade effect. And so what I'm going to do is turn my DEM on. And if we didn't have blending modes at our disposal, the way we would have done this historically is to use transparency. So if I switch to this transparency tab for my DEM, I can start reducing the transparency of this and start being able to see the hillshade underneath. But we have this sweet spot around 75–70% where we get pretty good colors and still see the detail in the hillshade. And if we try to go too transparent, then we simply desaturate the colors, even though we see detail in the hillshade better. So it is possible to use a technique like that, but it's much more powerful to use a blending mode. So down here in the layer rendering section, we see blending mode normal. And I'm going to switch from normal to multiply. And what this will do is give me full saturation of all the colors in my DEM from that SDA color ramp, simultaneous with all the detail in the hillshade image. It blends those two layers together. And now there's one other renderer related to elevation that we can take a look at. So I'm going to again duplicate this DEM layer. I'm going to move this copy of it so it's the uppermost. And I'm going to rename this to contours. And for the time being, we have 2 copies of that colored DEM. So it's looking much more colorful here. But I'm going to, instead of using the single band pseudo color, I'm going to switch this to the contours renderer. And sometimes I've found that I have to reduce this input downscaling option to get the contours to show up. And I think now you can see these contours appearing on the map. With contours, there's this thing called an index contour. So the contours themselves represent an equal elevation along that line. And then every 5 lines, we have an index contour. And so you can set the interval in meters here for these contours. If you're using the Mons-Klint DEM, you're going to need to reduce this down to probably a 2-meter contour and a 10-meter index contour, something like that, because the elevation differences are smaller. This works pretty well for this example, just the defaults, and I'm just going to make the index contour symbol a little thicker. So I'm going to click on the symbol for that and just increase the width a few clicks so that those index contours stand out a little better. And those just give you a way to judge the elevation differences a little better when you're working with contours. And we have adopted the multiply blending mode since we duplicated the color DEM from that. So we can set this back to normal. We won't see a huge amount of difference there. It's hard to tell much change at all. But there are some other blending modes that work even better for contours on top of these other 2 layers. So I'm going to switch this to addition. And when we use addition, it's adding those color values together. So it creates the contours as white lines in this case. And so just to kind of give you some idea of why that's happening, if we look at the way colors are defined, QGIS by default uses red, blue, and green values. And so with red, green, and blue values, black is 0 and white is 255. So if you add color values together, you get to that 255 rather quickly. And so this addition blending mode is adding colors together that are stacked on top of one another. And so often the addition blending mode will result in this kind of the data turning white like this. There's some others that we can also use. See, I think overlay is also an interesting one to look at with this. If I zoom in a little bit better, we can see it. So it makes these contours still part of the map, but a little more subtle and not dominating it as much. And the soft light is another one that's similar. And I think even difference. So again, with these blending modes, you have to just kind of flip between them sometimes and figure out which one is going to give you the most pleasing effect for the data that you're working with. But for these contours, there's at least 4 that will allow these contours to still be visible, but not dominate the map and kind of make a very nice rendering. And I think this is, it's very nice in QGIS how we can very quickly start with a raw DEM and come out with a beautiful terrain visualization just by using renderers and not having to produce any extra data. We'll take a break here, but before we do, there's one more thing I want to show you in this project about blending modes. There's a print composition in here. And the point here is that blending modes are kind of found throughout the QGIS interface. So you can use these for other objects besides data. So for example, there's this logo that was actually made by Klaas Carlson, who did the legend pad shapes that we downloaded. And it says made with QGIS, and it has this black and white. So a lot of times a corporate logo will have, or an organization logo will have white around the text. And sometimes the graphic designer will spend time creating a transparent version of that for use in maps and things like that. But even if you have not created a transparent version of the logo, you can use a blending mode in a print composition to strip that white out. automatically. And it's the multiply blending mode that'll do that. So if I select this logo and go to item properties, I can expand the rendering section, and I can see that we have blending modes available for this image, this logo. So I can choose multiply, and it strips the white out of that logo. And so again, this is one of these situations where you may need to experiment with different blending modes. The soft light one kind of does the opposite, where it leaves the white and removes some of the black. And so some of these will work quite well. Again, it's going to be data dependent, depends on the logo, depends on the map. But they're available for all these features, even the legend. So just keep that in mind as you're putting together maps and you're maybe running into a challenging situation, that you can always use a blending mode for things like that to help out. And sometimes they are just what you need. Okay, so we are at the top of the hour. So let's take a 5-minute break and reconvene.
Great. See you in 5 minutes.
Yes. Okay, so far we've looked at a couple blending modes, and again, the most common use case for them here. We're now going to look at what's called feature blending mode. So I'm going to remember where that project comes from. In the blending folder, there's a geo package, and there's a project called DK Roads. So this is a map with obviously a dark background, looking at Shelland here, and we have maps or roads from OpenStreetMap, and they're this blue color. And one really nice use case of feature blending modes is to render density of features. So if we use layer blending mode, it's applying that blending to the entire feature. If we use feature blending mode, it's applying it at the feature level. So here we have, or in Copenhagen, the OpenStreetMap roads are so dense that it just turns into a blue blob. We're not actually able to distinguish the individual road arcs at this scale. So if we use a feature blending mode of addition, it's going to add the RGB values for these blue roads together, and where they are most dense, they'll become kind of bright white. So this is a blending mode that is scale dependent, but is a very nice way of showing the density of a feature, in this case, roads. And it's going to change as I zoom in. So if I zoom into North Shelland, it's going to change because as you zoom in, fewer and fewer roads are overlapping one another at that scale. But you can see all the summer house roads along the coast and Copenhagen at this scale. So this is a real favorite of mine, and I've used it in other use cases. So for example, this is a map of 24 hours of ship traffic around Denmark from AIS data. And again, I used the same feature blending mode of addition on these. I would have used this for this course, but this was a huge data set with generated from like 9 million points. So it was just too large for a course. But again, a really great technique for visualization where you're really trying to show magnitude like that. And very easy to apply. So I think that's probably the most commonly used blending mode at the feature level. I've seen some use cases for Dodge as well, but again, it kind of takes experimentation with those. I think, as a matter of fact, I know these were all added because these are all standard blending modes that there are algorithms published for, and that's why they also appear in Adobe products and Inkscape and GIMP. So these were all just added without recipes already in place for their use. And it's just taken people like Anita Grazer to come up with interesting ways of using them through experimentation. So the next topic is going to be rendering points. So we're going to go into the points folder here. I'm going to open up this points project. This is a similar map, same dark background, and we have places. So these are named places, again, pulled out of OpenStreetMap for Denmark. So there's a lot of points here. There are, if I right click and choose show feature count, almost 7,000 points. And they're getting so dense, again, like the roads, that we can't distinguish individual points. So one of the real useful renderers to use in a situation like this is the point cluster renderer. So if I turn that on, it will keep the default kind of lime green symbology for the individual points, but whenever there are more than one point symbol stacked on top of one another, it replaces it with this larger symbol with the number that tells how many points are stacked in that location. And you can, of course, this is just the default setting. You can go into the cluster symbol, which is wherever there are clustered points, and you can change the color. You can see this is a small symbol stack using the simple marker for the red point, and then the font marker below. And so you can change these. So, you know, for example, we could change the color of this to match the lime green, or choose a different green for the clusters. And you can change the font color as well, the font that's used. So all of these components of the symbol are manipulable. And this will change as we zoom in and zoom out. So that's the cluster symbol. And then under the render settings, you can change the symbol for the individual points. And all the same things we've looked at, blending modes and layer effects, could apply to a symbology like this as well. So let me make a copy of this. I'm going to put it back at its single symbol. And the next thing I'll look at is the heat map. Rename this layer heat map. So the heat map renderer, again, it's possible in QGIS. There are algorithms for generating heat maps, interpolating points into a raster surface, but we can also just render these as a heat map. And this is usually just a quicker way of seeing what that might look like. Sometimes it works in practice. Sometimes you might actually want to develop a real raster layer as a heat map. But the heat map renderer definitely has some nice uses. If we turn it on, it's going to, by default, have the black to white color ramp. So again, we can change this to something that's a little more interesting, like which one I was going to use. Yeah, red, yellow, green. And then invert the color ramp so that the dense clusters of points have red. And we can also change the search radius. So if you change the search radius, it's changing how far QGIS is looking. In this case, millimeters on the screen to find points for that heat map. And you can change the units of this. You can even change it to be meters at scale, which could be useful to come up with a more real world rendering of density by meters at scale. And there's also a weighting option. So in this case, we have, if we open up the attribute table for this data set, there's a population column. So we could weight this heat map by population. And of course, Copenhagen is going to pop out along with the other large cities in Denmark, Aarhus, Aalborg. So that's another possibility. And this renderer also, let's see, can we just turn that on? There's also a quality slider here. So you can slide it over to the best quality, which is going to take quite a bit more time to render, or the fastest. And that really just affects the kind of the pixel size of the underlying representation. And we can also use this in combination with a blending mode so that we can see the underlying map. So we could use addition for this, or multiply, so that we can see the map underneath. You might also, in this case, this might be a case where you want to try the opacity slider instead of using a blending mode. And you can also, sometimes it's desirable to use both in combination. A little bit of opacity along with the blending mode can also be a nice effect sometimes. And if we go back to the original data, this could also be a use case for a feature blending mode. You could also try the feature blending mode of addition here. And if we were using, again, a darker symbol for these points, you would get an effect for these similar to the one that we had for roads, where we're able to see the density of these points by zoom level. So a number of ways that we can deal with points. There's also another renderer in here that we didn't look at. Turn off the blending mode. There's another blending mode in here, point displacement. This one is a little tricky to use because what it's going to do is physically move the points away from their location. Excuse me. So you have to really use this carefully and set it up so that you're not lying too much with the data. You'll see there's a center point for the distribution, which is where the point actually originally fell. So you may choose to turn that off and not use that, or make it a very small point. In other words, zero size, zero color, so we don't see that. And then in the render settings with this one, you can, or here it is, the placement method. There are several different placement methods: ring, concentric rings, and grid. And so the default settings are usually pretty severe. So usually when I'm trying to use this, I'm knocking down the distance considerably. There's also a displacement line symbol that I usually like to get rid of if I'm using this. So I'm not seeing that, I'm just seeing the points. And so if we start zooming in to North Shetland here, we can see the points a little bit better. We can compare that to the original data. So you can see the original points in green and the new displaced points in blue. And sometimes that can be another way of showing where those points are actually falling. But of course, they're not in their intended location, which is usually the whole point of a GIS. So it's one that you have to use with caution. So the last thing we're going to take a look at this morning are coastal effects. There's a number of nice ways you can use some of these renderers in QGIS to come up with more interesting effects than just a blue for a coastline or water bodies. So I'm going to open up in the Denmark folder. There's a coastlines project. So here we have a map centered on some islands in southern Denmark. And so we can use this to experiment with some coastal effects in QGIS. And so what we're going to do is use this effect called an inverted polygon shape burst fill. And this can also be used, the same technique, for delineating a mask around the study area. So in this case, I'm going to take this layer in municipalities, which is essentially our land, and I'm going to duplicate this. I'm going to put this above municipalities, and I'm going to turn it on, and I'm going to rename it water. So there's a very interesting renderer in QGIS that's called inverted polygons. So when I use this, it's going to convert the land into water, basically. It's going to invert this layer. And this is only for use with polygons. It'll invert the polygons to make it the opposite of what it is, just in the way it's being rendered. So when I do this, I end up with a solid brown map because I have one version of the municipalities as the land and one as water, because I'm using inverted polygons for that. So next, I'm going to change from a simple fill, and I'm going to use one of these symbol layer types. I'm going to use the shape burst fill. And now I just need to get out of these beiges into something that looks a little bit more like water. So I'm going to use this two color method, which will basically create a color ramp between these two colors. And I'll make the first color, I'm going to put in a specific RGB value. It's going to be 225, 255, 255. That makes a nice pale blue. And then the second color will be a darker blue. This is going to be 166, 206, 227. So now, very quickly, I've gotten at least water represented, but I can enhance this a little bit. When you're implementing the shape burst fill, by default, it's using the shading style of whole shape. And we want to instead use the set distance setting. And this will allow us to set the distance from the polygon edge where the transition from one color to the other occurs. And so this is in millimeters by default. You have all the other units to also use. I'm going to set this to a couple of clicks up to 7 to create a slightly larger spread here. And we also have this blur strength down here. So again, this will control how smoothly those two colors blend between each other. So in this case, I'm going to increase this to create a smoother effect between the two. And I think in the directions, I put this all the way up to like 15, near the maximum blur strength. So very quickly, we have a nice ocean effect here for the islands. And I like this again because we didn't actually have to create a water layer to do this. We just inverted the land and styled it to create this effect. So the next thing we're going to do is experiment with another coastal technique, which is called Ben Ray dots. So Ben Ray dots is basically the technology that's used in newsprint to print photographs in newspaper. You know, if you look with a magnifying glass, you see the individual dots making up the image. So cartographers have been using this kind of same technique to create kind of the stippled effect along a coastline on a map. So we can use some tools in QGIS to create something very similar. So I'm again going to duplicate this municipalities layer, and I'll call this copy dots. I'm going to move this above that water layer, and I'll turn off the water layer for now. So I'm again going to be using that inverted polygon renderer. But instead of a shape burst fill, I'm going to be using the point pattern fill. So point pattern fill is going to allow me to fill this polygon with an array of point symbols. And by default, there are these big, ugly red points. We'll fix that here. So one thing I want to do to create these Ben Ray dot effects is put the dots closer together and not have them be on a perfect grid. We want them to kind of be staggered diagonally, so it creates a more organic looking grid. So if I select the point pattern fill component, we have a number of different settings for it, and I'm going to adjust the horizontal and vertical distance. I'm going to set the horizontal distance to 1.5. Put them very close together, and the vertical distance to 1.2. And now they're so dense, they're kind of hard to see. So we need to make the points a little bit smaller. And let's see, I'm going to use that same blue color we used previously for the dark blue for the shape burst fill. It's going to be 166. 206, 227. And I'm going to use a stroke style of no pen so that I just have those, and I'll reduce the size all the way down to something like 0.8. So now we have a much tighter array of blue dots. There's one more setting in this point pattern fill we need to do so that they're not a regular grid, so that they're shifted a little bit. And that is this horizontal displacement. So we're going to shift the horizontal displacement of these points a little bit to 0.75. And you can see when I do that, I'm not sure how well this shows up on Zoom, but they're now shifted so that one point is in between other, almost the way bricks are laid out in a building. They're offset. So now we're going to add another symbol layer to the stack. So we have a point pattern fill set up, and we're going to click this green plus button to add another symbol. That will always be a simple fill by default. This one, we are going to make a shape burst fill. So I'll set this one to shape burst fill. And let's see, yeah, there's a little interesting bug here. I want to make the first color completely transparent, but I've noticed that if I just do this without changing the color to white, it sometimes doesn't work. So I'm going to change this first color to white. And then I'm going to click here and change it to transparent. And the second color is going to stay white. And I'm going to use this set distance technique. And so now you're starting to see this effect where we have just those dots occurring kind of as a stippling around the coastline. And you can control how tight that is to the coastline by this set distance argument. So I may want to, reduce that to make them a little tighter to the coast. And again, we can increase the blur strength of this shape burst fill so that it's smooth, it's a little smoother. And so now we have kind of a, this is an effect that on some maps may work, just a subtle stippling around the islands creates a little more interesting map than we would have had just with a white background. But we can now also turn on this water layer. And we're going to select the shape burst fill component. And I'm going to see, what did I bring up my reference map here? Yeah, we're going to set this first color to the dark blue. And I can just use the pick color tool to pick this dark blue. And we'll set this, we're just going to basically invert those colors. Set this one to the 225, 255, 255. And finally, we want to employ a blending mode. So on this dots layer, I'm going to expand layer rendering and use the multiply blending mode. And so now we have this kind of combination of those two, where we have in the area near the coast, the Ben Ray dots showing up, and the kind of the blue shape burst fill beyond that. And again, we can go in here and tweak this. We can play with the distance of the shape burst fills, especially this one associated with the Ben Ray dots, to make it a little, to control how far away from the coast you see those points. But yeah, a very nice effect. And the last thing here that I would like to show, which is a segue into the next course, is that there is there's another very popular coastline rendering effect, which is exponential coastline buffers. And there's a way to, well, one obvious way to do these is to produce a series of buffers around the land at specific distances, merge them all together and symbolize them. But we can also use something we're going to cover in the next class, geometry generators, to create this kind of effect as well. It's computationally intensive, but it is possible to do it. So this is the, oops, shouldn't have gotten out. So this is the same area shown with these exponential coastline buffers. And you can see that here we're using, again, the inverted polygon renderer for the municipalities, but we're using the geometry generator instead of the shape burst fill or the point pattern fill. And when we use the geometry generator, we can choose the geometry type of the data. So we're going to choose line string in this example. And we're basically using an expression which adjusts, we want this distance to be exponential. And this can depend on the scale of your data, where, how far out you want these contours to be set. So with this expression, you're going to set it up with a series of values that are going to be fed into this expression with the exponent function in QGIS. And we can then tweak the values in here for different use cases to extend those buffers farther or bring them closer into the coast. But it will always be a series of 10 buffer lines that are, where their distances are exponential between 0 and X distance from the coast. And again, this on my laptop takes a minute or two to render, and I've just selected a small group of islands. It's not all of Denmark. So this can be an expensive computational way to go, but you can also, the fact that it's a geometry generator makes it equally applicable to almost every data set. Just a matter of tweaking the values in there to work for your particular map. And I do have the expression here. And actually, there is in the course data, I think I included this as a style that you can apply, and then you can tinker with the expression. So if we go into the data for the course, yeah, there's an exponential coastal buffers QML file that you can use to apply to a data set, and then work with those values to adjust it. And this actually brings me to one thing I should have mentioned earlier. When we go into the QGIS Style Manager, one of the new features of this is that there's now a button down here to browse online styles. If I bring up the web page for this, this is a site where the QGIS community can upload different styles for various things. And some of these are color ramps for rasters. Some of these are legend patch shapes. Some are for lines, points, polygons. Some of these are just silly styles. Some of them are very practical, but this is actually where I found the style, because Klaas Carlson developed this style for exponential coastline buffers, and it's in here somewhere. It's on the next page. So that's where I downloaded it and tinkered with it a little bit for this use case. There's also a Tanaka contours, which again is another use of geometry generators. So there's a lot up in here that you can download any of these and apply them to your data. Not all of these are geometry generators, just some are just symbol stacks, but there are many in here that are related to geometry generators. And we'll be covering that topic more in the next class period as well. So we finished a little early. Do you have any questions, or is there anything else you'd like to discuss or look at?
Yeah, I have a question, if it's all right. It's about the coastal lines. So say that you wanted a similar effect of the exponential coastal line buffers, but that you are not in the mood of writing the expression, or that you do not want to run an algorithm to create buffers you have to set. Could you imagine that you would take and duplicate the layer 4 times, and then in the style manager just set it only to show lines, and then offset the line in styling to create a similar effect? Could that be an approach?
Sure,
like
could.
A fast one? Okay.
Yeah, it absolutely could. Yeah, and you just maybe have 5 or 10 copies of the layer, each with a different offset, or okay. or really there's just a buffer function in QGIS. So you could just, if you knew the distances, you could just use the geometry generator to buffer each copy of that layer by a different distance.
Oh, okay.
And apply the same style to each one, and that would be pretty much less computationally intensive. The buffer function is usually pretty quick in QGIS if it's just a single buffer.
Yeah, I mean, it sometimes it is, but it's mostly that we use the buffer algorithm a few times, but of course it generates a new layer for every buffer that you either have to store somewhere or, you know, handle together. So this was just to imagine that you made a copy of the layers you already have and then, you know, do a quick styling.
Yep, absolutely. Because then you could simply copy and paste the style across all the layers and it would be fairly quick.
Yeah.
And that's a nice technique also for lakes. So it's a nice way to style interior exponential buffers for lakes. This is another use of that. So certainly.
Great. Thanks.
Yeah, you're very welcome. So I will be emailing you a link to the recording of this session and the assignment document, which has all of the links to the videos for individual sections that we covered today.
Great.
Thanks so much.
Yeah, thank you. Can I ask one more question?